Hey everyone, I just wanted to do a quick video on my recently acquired Vornado 184 tower fan. I've seen a number of other YouTube videos and reviewing this fan, and also reading through some of the comments. I've seen some people complaining about how these fans prematurely fail, and I just wanted to share some information that might help some people diagnose what their problem might be with their fans. I was able to fix this fan. I picked it up from Craigslist from someone who was using this fan as a warranty return. The fan had just stopped working, so they contacted Vornado. I guess they have a very good warranty return policy. All the person has to do is cut the cord at the base of the fan, take a photo, send it to Vornado with their serial number, and if it's within the warranty period, Vornado will send them a brand new fan. They don't ask that you return the old fan. So the person that I picked this fan up from did that that exact process. They cut the cord, power cord at the bottom at the base, and they sent their fan to, or sent the photo information to Vornado, and they ended up receiving a new fan. And not wanting to just throw this in the garbage, they put it on Craigslist. So I picked it up and started working on it. And the first thing that you need to do is basically or not run, but unscrew about 7 or 8 screws, I guess, on the outside. These are essentially being screwed into plastic, so you have to be very careful with it, or you can just crack the plastic. And I'll also say that I think that the plastic that this fan is made out of is kind of brittle. That's the way I would describe it. It's not the most expensive or the highest quality plastic, I don't think. So just be careful when you're dealing with the screws. Also, to take note, there are different sized screws, so you have to keep track of which screw came out of which hole, because when you're putting this back together, you don't want to put the wrong screw in the wrong hole. So just keep that in mind. The first thing that you see when you remove the cover is basically dust. Well, this one's not so bad. But you will reveal basically the motor at the base, and connecting the motor is a long cable. The motor is located at the bottom of the fan, and the cable connects to the top of the fan, which is where you will find the circuit board with your buttons and essentially the brain of the fan. All of your power coming in through the power cord at the bottom is directed up to the circuit board, and then from the circuit board the controls are sent back down some wires to the motor. So the motor doesn't receive direct power from the power cord. It goes up to the circuit board and then back down to the motor. And the person who I got this fan from didn't know what the issue was. So basically I was starting from scratch. I had no idea what to look for. And so I started looking through any obvious problems with the circuit board. Is there anything burnt out? Did I notice any black scorch marks? The circuit board was actually very clean. There wasn't really any issues with anything visibly. And so I also looked at the motor to see if there was any burn marks or anything like that. And the motor looked really good as well. The motor is just secured on with a couple of screws. You can undo those. You can pull the motor right out. And there's 4 screws keeping the motor, the 2 parts of the motor together. You take the 4 screws off, you can separate the motor and then see the windings, which is what you see here in the photo. Something to note, and I did test for this, is that there's a thermal fuse located in one of those white sleeves. The thermal fuse, of course, is there as a safety measure. In the event that the motor overheats, the thermal fuse will blow out and turn power off, shut the whole fan down. With the thermal fuse, I can't remember exactly which sleeve it was, but if you open it up, you can definitely see that there's a slightly larger white sleeve, and that's probably where you'll find the thermal fuse. That's certainly the case with this fan. I did a continuity test with my multimeter, and instead of having to pull the entire sleeve off to visually inspect the thermal fuse, I just put one lead of the multimeter to one side of it, and the other lead to the other side, just to test for continuity to make sure that the thermal fuse wasn't burnt out. I received a tone, so the continuity was fine, showing that the thermal fuse was still intact and that there was no issues. Since I didn't see any other visible problems with the motor, I thought that I would probably be best to spend my time looking at any issues with the circuit board, because basically the power was getting to the circuit board. I used my multimeter to test for voltage at the live and the neutral on the circuit board. You can see the wires are at the bottom left, and I just found that I was receiving voltage at the circuit board from the power cord, which I had to reattach. I don't think I mentioned that earlier. Basically, the person who had this before me had cut it, so I had to sort of strip back a small portion of the cable, which he included. He still kept the power cord. It was just that it was cut. So I stripped back the two ends and fed it into the motor at the base and reconnected the power cord. You can see that in the photo where I'm not sure what to call those two insulated caps, those white caps are located. I had to pull those off and pull off the old power cord connection and then just reconnect the cable. And then I put a couple of wire nuts over top of where those white clear caps used to be. So I had to reconnect the power. Anyway, I had to go back in time there for a second. So the power was fine after I reconnected them. And then I tested it at the circuit board, as I mentioned, and it's fine. It receives the power. So then I started looking around at what else could be the problem. And you'll see that on the circuit board there's a number of components. There's some capacitors, there's a number of resistors, there's a handful of diodes. But these are all very easy to test with a multimeter. And some of them require that you disable or unsolder at least one of the leads from each component so that you're able to properly test them, because it's not always accurate to test a component when it's in circuit. So on those particular components, I think I started with the capacitors, the electrolytic capacitors. There's only two of them on there. And because in my experience I've found that those tend to be the first things to go, when I looked at them, I determined that the capacitors, both of the capacitors, there's a 1,000 microfarad capacitor, and then there's a smaller one. I can't remember the exact capacity for it. I think it's 10 microfarads. It's a small one. And while I think that they were still okay, they certainly weren't burnt out or anything, but they were measuring low on their tolerance. I think it was on the 1,000 microfarad, I think it was measuring just slightly above 800 microfarads, so that's almost 20% out of its rated spec. So I swapped it out for a different capacitor. Same with the smaller one. It seemed to measure a little bit low on its capacity, so I swapped that one out as well. So I resoldered those two capacitors and tested it again, and I still wasn't receiving any power. Then I went around and tested the diodes and made sure that they were measuring okay. I did desolder one lead from each diode and pulled it out of the board and then measured them that way. And all of them proved to show that they were okay, that the electricity was flowing in one direction, that the current was flowing in one direction. So I resoldered the leads and determined that they were fine. Uh, what else did I look at? I also tested the IC. There's the one IC chip there, just to see if there were any shorts in the IC by placing the, I believe I placed the negative lead on the power um, input for that IC, and I think it was pin number 5. You can find the IC information online. It is, geez, if I remember it. Well, I don't have that information again, so I can't remember exactly. But I think it was pin 5. I found the schematic for it and tested it. And then you place the negative on there and then move around to each pin to make sure you're getting a reading of around, I think it was half a volt, 0.5. And they all tested fine. There was no shorts. And in my experience, I tend to find that resistors tend to be the last thing to have a problem on boards. So I didn't do those right away, but I eventually did get around to start looking at the resistors. And eventually, I came to the large resistor, which is next to the live and neutral and common wires at the bottom of the circuit board. It's supposed to be a 10 ohm resistor. It looks like it's either 1 watt or 2 watts, judging by the size of the resistor, but I wasn't positive. But I did pull it out and test it, and while it's supposed to be 10 ohms, it ended up measuring something like 12 mega ohms. So obviously this was way out of spec and could very well be the source of my problem. So I went and picked up a new 10 ohm resistor, a 2 watt 10 ohm resistor from my local electronics store, reattached it, and the fan worked. So I was able to determine that the resistor, the 10 ohm resistor, was the problem. Once I installed that, the fan worked completely fine. Obviously, the power was not getting through that resistor, and that was essentially why the circuit board wasn't receiving any power and wasn't receiving any, well, just wasn't receiving the power. So if you have a problem with your Vornado fan and are unsure about what the problem is, perhaps there was a manufacturing problem with these particular components. Maybe your resistor in the same spot is also a problem. I mean, it's easy to test. In fact, I think I was able to test that particular resistor in circuit. I don't think I even initially took it out. I tested it in circuit, and it was way out. So then I desoldered one of the leads and checked it again, and it was the same reading. So you might be able to just get your multimeter on that and just test it for its value and see if that's your problem. Okay, so I put it all back together. Everything works fine now, and it's great that the previous owner didn't just throw it into the trash, because really it cost me 60 cents and a couple of hours of diagnostic time to figure out what the problem was. It's not an overly complicated circuit board. As I said, you can test almost everything on there with a multimeter. I should also say that I've tested the buttons for continuity, just to make sure that when you press the button, it was getting continuity on the other side of the trace. And I should also mention that, of course, this is alternating current voltage. There is no rectifier on this circuit board, so you are dealing with high voltage. If you're going to open up your fan, you have to be extremely careful. I don't recommend you do this if you're not comfortable working with electricity. For the most part, the testing was done with the fan unplugged. The only time I had to have the fan plugged in to do any testing was just to see if there was voltage reaching the circuit board. Everything else was done with the fan unplugged. And also should mention that there's a teeny tiny fuse that measures around, I'm not sure if it's like 3 or 4 millimeters, in the base of the plug where it goes into the wall. There's a little sliding door. You just push it aside If you're not receiving any power, you should test that fuse to make sure it isn't blown, because that could very well be your problem as well. Anyway, I hope this helped with anybody that's having issues with a Vornado fan. In fact, maybe it sort of leads you into a solution with a different brand. I don't know. I hope everyone has a great day. Thanks for watching.